Hello student, here is in this question, in a coaxial straight cable, central conductor and outer conductor. Central conductor coaxial cable is a central conductor, and another one is outer conductor. This is the outer conductor, are carrying equal and opposite charges. Okay, let's say that's current in this one is out. Okay, that's equal to I, and here is in this conductor current is inward. Okay, so it is again I, same amount of current but in opposite directions. Magnetic field is 0. So you can see that's if you are applying the Ampere's law. So according to Ampere's law, here in inside there is no current. Okay, so I will write that's for 1. Okay, so for B1, integration B1 vector dot dl vector is equal to mu naught into I, that's equal to 0. Okay, so B1 will be equal to 0. So inside, okay, inside both the center, both the conductor, there will be a 0 magnetic field. If you are calculating the magnetic field at this point in between the conductor, so in between the conductors, so it will be equal to, let's say that's 2 surface loop number 2. So that's equal to integration B vector dot dl vector, that's equal to mu naught into current inside the loop, that's ampere loop, that's a 2, that's equal to I. So you will write that's B is equal to mu naught into I upon 2 pi r. So here in that case it's not equal to, that's radius is r1, so this radius is r1. Okay, so here is the radius r1 and here is radius is r2. Okay, so this is the 2 pi r, so is the distance, so is the 2 pi into r. Okay, so that magnetic field is not 0 in between the, if loop is in between the conductors. Okay, so it's not 0, magnetic field is not 0 in between the conductor, so B2 is not 0. Now come to the third loop, that is outside. So here is the loop which you have, this is the outside loop, and for outside loop you can see that's B3. So I am writing the Ampere's loop, Ampere's law again, that's B3 into dl vector is equal to mu naught into summation I. You can see the total current, one is going inward and another is coming out. Into one is into the plane, another is out to the plane, so total sum will be equal to 0. Again you can see that's B3 dot dl, that's coming out to be 0. So you can see from there that's B3 is equal to 0. So for an outside point of the outer conductor, the magnetic field will be equal to 0. So magnetic field is 0 outside the cable, so that's correct. Outside the cable, outside the cable 1, it's not 0. Outside the cable, outer cable, it's 0. Inside the inner conductor, inside the inner conductor, that's equal to 0. And outside the cable, coaxial straight cable, inside the inner cable, inside the inner cable, that's the inner cable, that's equal to 0. Okay, so outside the cable, inside the outer conductor, inside inner conductor, inside the inner conductor, and inside the outer conductor, inside the outer conductor, between the conductor, it's not 0. Outside the cable, it's equal to 0. Okay, so outside the cable is straight cable, coaxial cable. If it is outside both the cable, central or this is both the cable, current carrying equal, coaxial cable is there. Or if this is like that, if this is the cable, coaxial cable, straight cable, or central conductor and outer conductor, if this cable is like that, if it's not hollow, in that case you cannot say that is equal to 0. Okay, so if it is like that, key like this one, then in that case inside will not be 0. Okay, so outside will be 0. Inside the outer conductor, it will inside the hollow. If its cable is like that, okay, so if it is like that, it's not hollow. Okay, in that case you can see that current is not 0. Okay, so that current will be some amount. Okay, so that's in whatever the you have the loop, whatever the amount of current in that Ampere's loop, that will be the current in that case. If this is not hollow conductors, okay, so it will be like that. So in this case magnetic field will not be 0. And if you are considering the loop, so it's outside, it is having the current, it's not 0, but outer to the outside the cable net current will be equal to 0. So if you are considering that that these are the solid cables, okay, so here is the inner cable and this is the outer cable. So inner cable, you can see at inner ampere loop there will be some current, and that current can be calculated by density will be given to you. In that case you can just calculate some amount of current will be there in this ampere loop if you are considering. So here is the current you have to write. So B1 will not be 0 in that case. B2 will also not be 0, because here in that case you can see that there will be a current inside that loop, okay, so it will not be 0. B4 will be 0. Now B3 will be 0, because for outside point there is not net current, that I and that total inside current, that will be equal to net current is 0. So for an outside point, outside to the point, it will be 0. So option number first is the correct answer of this question. Okay, thank you.